There is a concept, and it has taken the 3D world by storm, and it's easy to see why. You can create thousands of unique 3D objects in seconds, and then animate them with only a few keyframes. Now, it's in Unreal Engine. And if you stick around through this video, I'll show you what aspects of Cinema 4D have made it into Unreal Engine already. To be real for a second, procedural content generation has been around for decades. The idea behind it is that if you have anything like a city or a forest or anything involving dense duplication with some variance, then setting up a set of rules for complexity is always going to be more efficient than explicitly authoring every single object itself. Some programs have lent into it more than others. It's the secret sauce of Houdini and Cinema 4D. However, recently there's been some moves from other programs into that space. Blender especially has come in with geometry nodes and now simulation nodes, but Unreal Engine as well, with its 5.2 release, came out with procedural content generation. And when I saw that, I wondered if I could make it a little bit more like Cinema 4D. So we're going to be blasting through this, and you're going to need these things on screen. And if you're just beginning in PCG, you'll want to do my other tutorial, which is linked here. The important part is that you'll want to be able to get a PCG component into a blueprint. So there's two large ideas that we want to hit on here today. We need to get data into the clones so that we can control every single one. So that's like saying, I need to stamp every single one of these clones with some form of an ID. And the way that I'm going to do that is I'm going to stamp it with a locational based ID so that I can tell what part of the volume it is located in. And here's one that I made earlier. The way I've set it up is that I'm generating a point grid in the PCG graph using some variables that I set up in the blueprint. We give it a box size and the number of points in each axis, and those numbers get sent into the PCG graph. Once inside that graph, we use those numbers to not only make the grid, we also use it to calculate where each point is in relation to the overall cube, then pack it in an attribute that gets transferred down onto every instance. Secondly, we need to set up how the clone responds to being controlled. So if I send the clone any data, I want to set up whether it expands, contracts, glows, rotates, whatever. That's done at the material and shader level. Every single instance gets the same material, and that material looks for the XYZ coordinate in this, the per instance custom data. Now, this whole material looks complex, and it kind of is, but overall, it's just using that XYZ coordinate to sample a volume texture and then using that number to do some funky things. We've got emission and color to give it the glow. I'm offsetting it all using a sine wave so that we can just leave it animate and it'll go forever. What's interesting to me is that at this level, we can also alter each instance at a vertex level using world position offset. There's a bunch of vector math here, but you can see I've grouped it into making the instances scale, offset along the given rotation, and down here, I've begun to experiment with bringing in data from external objects that I'm piping through a material parameter collection. That means I can start to approximate what Cinema 4D does with its fields feature. That's really the key to all of this procedural stuff. The possibilities are almost endless.